I told you today, I'll just aware on this networking concept. Elizabeth, her kid is not feeling well, I guess. She told us something, and she'll be joining soon. I guess today she's supposed to join. Not sure tomorrow I can expect her. Let me write some terminology here. Here is the router A, router B, LAN, we call it as E0, LAN interface. I guess you are aware of this router, serial S0, S1, S0, E1. So, okay, here I can see switch. See, in switch we have two types, a modular switch and non-modular switch. Modular switch means we can further add on components to this switch. Non-modular switch means those are called fixed switch. So switch is a layer 2 component. It works on frames, LAN frames. So computer transfer the data through cable in the form of bits, and it will be carried over to the other device through copper wires. And these bits are group of bits together. It form the frame, and frame contains the LAN interfaces. See, just a minute, I just want to. See, every LAN interface will have the physical address. You can see the physical address. So 00167680, this is a physical address. So every LAN interface, our computer will have the LAN interface. We call it as a LAN card or a modem or any other interface that carries the data from one system to another system. It is called LAN interface. LAN interface will have a physical address, which is used to communicate within the LAN. So this every computer will have a LAN interface. Computers. Computers. So these computers are connected to the switch, and each computer will have an IP address. Address.
Buddy still there? Yes, I'm still here. Okay. And you can hear me. Yeah, I can hear you. So the problem is with him.
Yeah, and I think Elizabeth died, so I don't know about. Let's see what he says from the chat. He's chatting. Don't know the problem. Everything is fine from my side.
I'm going to hang up and start the whole session again.
Yeah, me too. I think I'm going to try that.
Hello? Hello? Can you hear me now? Okay. Okay. I don't know what's the problem. Uh-huh. I can see I can hear your voice. Okay. Uh-huh. Hello? Can you hear me now? Okay. Yeah. See, I'm just giving an example here. See, computers will be connected to the switches. Switch will have its capacity, just 12 port switch, 24 port switch, 48 port switch, and they depend upon the switch type. And these switches are modular switches and non-modular switches. Modular switches means you can add on cords into the switch, means you can increase your number of ports in the existing switch. So these switches are connected in the LAN. These switches are called LAN switches. So all the computers will connect to this switch, and our computer will go to our computer will communicate the other computers via these switches. And switches are not represented with any IPs. So let me just trace. So here I can just trace it yahoo.com. I just want to reach yahoo.com, and I just want to see how can I reach to this yahoo.com. See, first it will go to my gateway. This is my gateway, and after that it will go to another gateway, and finally it reached to the yahoo.com. You can see here. So this is my route to reach the yahoo.com domain. So this is my path, the root path of from my computer to yahoo.com. Yeah, trace ERT. So the switch IP is nowhere. I got the router IP. This router is my gateway. So computer will via switch it will reach to the router, and there is no switch is just like to accelerate my my request to the router, my request to the other computer. It accelerates. So switches will work in the layer 2, and layer 2 accepts frames. Frames means frames doesn't have any IP addresses. It won't understand the IP addresses. So when it comes to the router, routers called as the gateways. We call it as gateways. Routers are used to route the source IP to target IP between the networks. It allows computers to communicate between the networks. I'll give an example. So I'm using a series IP here, 192.168.0.0 series. This is my network, my computer network, and the first machine IP address I'll write here, 192.168.0.1. This is my IP, the first computer IP, and the second computer IP. Can write here 192.168.0.2 3 4. So what is my network? 192.168.0.0 is the network. In this network my computer IP is 0.1, the second system IP is 0.2, 0.3 and 0.4. These four computers are connecting to the router via switch. Switch just it will pass the my computer signal to the router. Router has two interfaces. One is the LAN interface, the other one is serial interface. We call it as LAN and WAN interfaces. One is inbound signal, the other one is called outbound signal. So router will have inbound signal and outbound signal. Inbound means it accepts the signal from the intranet, internal computers, company computers, and the computer signal will be sent to outside via the WAN link, WAN port. So this router inbound interface will have an IP 192.168.0.100. I'm giving an IP address even. The even port is it's called a port, LAN port in the router, and this port has the IP address 192.168.0.100. So you can see here. See what is the default gateway of my IP address is 192.168.50.54. Subnet mask, I'll tell you about subnet mask and what is subnet mask. And the default gateway is 192.168.50.3. So this gateway is my default gateway. Means it should be in the same network. These computers, this is my for all these computers, this is my gateway. Because this computer has to communicate to this inbound port of the router. It should be in the same network. So 192.168.0 series 192.168.0 series. Both are in the same series. It can directly communicate. So my gateway should be in the same network so that I can communicate with the gateway. So all these computers will communicate to this gateway and it will enter in the router. Based upon the configuration of the router, the router will pass the signal to outside world. And this serial interface, just awareing you how the network will 202.65.136.100. I'm giving an IP. Okay, instead of all this, 200.200.0.1 is my serial port. S1 serial port and IP. And here I have another serial port at destination router 200.200.0.2. You can see serial line, router serial line S0 and router the other serial line S0. They both are in the same network. So this is one LAN. This is completely one LAN. This completely is one LAN. You can see these connections are, I mean, it's a WAN, but you can see what network it is using. These are direct connections. Router to router is a direct connection. It uses 200.200.0.0 network. This is my 200.200.0.0 network. And this is my 192.168.0.0 network. Router is the gateway. Yes. So I can write here 172.16.0.0 network. It means, let me take two computers here. This is one computer, the other computer, another computer. So my IP addresses for these three computers would be 172.16.0.1, 172.16.0.2, 172.16.0.3. Three computers, three IP addresses. So my LAN is the LAN interface, inbound interface here. Router inbound interface 172.16.0.100, because it should be in the same network. So if I want to reach 192.168.0.1 computer to 172.160.1 computer, if I press it, the next IP, the computer next goes to the 0.100 gateway, and from gateway it goes to the serial port, S1 serial port, from S1 to the 02 S0 serial port of router B, and from here it comes to the 172.160.100, and from there it goes to this computer. So that is a path of the root path of the source computer to the target computer. And I just want to have one more router here. And I want to connect to another serial port of the router. See, this router has two connections. One goes to the router A and another one goes to the router C. And here I have the serial port. It should be 200.200.0.3. S0. It is just a label given to the serial port, S0, RS1, RS2. It can be any. In the router, it is predefined to the router. And here I have one more. So I don't want to use the same network here. I want to use a different network. 156.0.10.10. This is my different network, and here 156.0.10.12. And here my serial port is S0/1. I'm just giving a different naming pattern so that you can understand. So what is this network? This network is 156.0 network. So computers, for this serial port, I should have one more LAN port. Goes to here. This is another connection, another LAN. Means a router can act as a multi-gateway. For this network it is a gateway, for this network it is a gateway. So router can be a gateway for multiple networks, and it will route to the different networks in the remote places. So this is the company network. This is I'm talking about, this is ABC company and ABC branch company, and each company will have a router and source and destination network. It allows you to connect from source to destination computer. In this way we will have the setup for every company. And what about internet? So we can connect to any part of the world. Internet means this router is in public. Your ISB router goes to the ISB office, Internet Service Provider's office, and from ISB office it will be connected to any part of the world, because all the ISB offices are integrated, and it integrates all the public networks. So I'm talking about private networks, means our corporate networks. Corporate network setups will be like this. It could be anything. It could be both. It could be either wireless or physical connection. A router will receive from ISDC. Directly I can't connect from router to router. See, I'll take one more. I'll just save this and I'll take another scenario. Okay. This is my router. And this router has a connection, goes to the network. connected to switch and switch to the network. From this router, the line goes to your local office, local vendor, and here is my remote vendor. Your ISP office, Internet Service Provider. The same scenario, the previous scenario, but I'm just giving an example here. Okay. ISP, Internet Service Provider. ISP, Internet Service Provider. We call it as backbone connection. And we call this as lease line. National lease line or International Private Lease Line, IPLN, or IPLS, we call it as IPLS. Lease line. But this is lease line means public line. You will be taking lease line for a period of time. You have to renew this lease period every time. So my network, my private network, is in at remote place, and at that remote place it will be connected to their local ISD office, and local ISD office to my place ISD office. There is a backbone connection. Internally it is dependent on intermediate nodes. This is suppose in Chicago, I have an office at Chicago. I have another office in New Jersey. So Chicago local ISD office to New Jersey ISD office, there will be a backbone connection. It means in this backbone connection you may have intermediate ISD offices. It will cross many ISD offices, and it will reach to your ISD office, and from there it will reach to your router, from router to your network. So I was talking about the tracer. Tracer Google.com. Tracer. IP config, yes. Tracer. So what is my gateway here? 192.168.50.3. Then first connection goes to 192.168.50.3. Again, see, these are all intermediate nodes, intermediate ISP officers or intermediate routers, and finally I will reach to the Google.com. This is an IP address. So it passes from all these nodes. These are called intermediate nodes. My computer signal is reaching to different ISP offices of different routers to reach to the Google.com. So similar to this, from here ISP office to ISP office, and the line from one ISP office to another ISP office, the communication line is called backbone communication. So it can be fiber or wireless. Fiber wireless communication. And this line is a cable. Fiber, cable, or Ethernet cable, depending upon the size, the distance. And this is also Ethernet cable. Ethernet cable is our LAN cable. So our LAN cables are called Ethernet cable. These are also, it can be fiber cable or it can be Ethernet cable. So this is how we, how the setup would be in the real scenario. So how do you, you will be accessing in this way your remote network. Now this is the gateway. Gateway, your router may have multiple, your different networks will have the same gateway. See, my company will have one gateway and I have 14 networks. All 14 networks can be connected to the gateway. Can be routed through single gateway. And here, I just want to implement firewall. All the networks. This is my complete network. The complete network connections will go out of my company from this router. When it goes out of this router, I implemented firewall here. I can implement firewall here. Inside firewall and outside firewall. We call it as inside firewall and outside firewall. Inside firewall means before router. Outside firewall means after router. So to track the signals and to monitor the outbound signals of the network, you can implement this firewall. Or firewall can be used to track or to block and to implement ACLs. Firewall will be used. So here also the same. The network team will do all these things. Just we need an awareness of the infrastructure. Your first job when you enter in the company is to understand the infrastructure. These are the very basic terminology. We must know how the signals will be routed, how many networks. Just for our understanding, and it is not mandatory to know, but for better troubleshooting techniques and for better understanding of infrastructure, it is must to understand these concepts in the organization. How do we use IP addresses to the computers? IP protocol is used to provide the addressing scheme. It gives the addresses, and these addresses can be allotted to the computers. Not only computers, to any node in the network, like computer, like switch, like router, like firewall. I can allot IP address. To identify the node in the network, we use an IP address. It's a logical address. To identify the network node, or to identify a node in the network. There are two versions, IP version 4, IP version 6. IP version 4 is, we call it as 32-bit addressing. IP version 6 is 128-bit addressing. Means the length of the bit. IP version 6 is not yet implemented in the internet, but our operating systems will support IP version 6. Solaris, Linux, Windows, all the operating systems will support IP version 6. Let us discuss IP version 4. It's a 32-bit addressing, as I told you. This 32-bit is divided into 4 octets, 8 bits, dot, 8 bits, dot, 8 bits, dot, 8 bits. So it is divided into 4 octets. 8 bits, 8 bits, 8 bits, 8 bits. Yes, 192.168.10.1. That way it has been divided. So, what is the maximum and minimum number I can store in the 8 bits? 8 bits contains 0000434. This is a binary number. So all zeros binary number will be 0 is a decimal number. 0. 1, 2, 3, 4, 5, 6, 7, 8. All ones binary numbers, if you convert this binary number, 8 ones binary number to decimal means you will get 255. The maximum number that I can use in the IP address is 255. So it means 0 to 255, altogether 256 numbers I can accommodate in each octet. It will be 0 to 255. Space 0 to 255, space 0 to 255. This is my representation, IP address representation. Four octets of this. In these 4 octets, these are the valid numbers. So I can't go more than this, out of this range. So which number has to be allotted to the computer or to a router or to a firewall? That depends on the type of network. So IP has given different classes. Class A. Before I go to class A, I just want to note every IP address has net ID and a host ID. It is just like your city. If you take the IP telephone number, you'll have the code, the city code, area code, and the telephone number. I can take the area code and the telephone number. This is my IP. IP address is logically divided into 2 parts. One is the net ID and the other one is the host ID. So if I am using, this is my IP address, 192.168.50.54. What is my network number and what is my host number? That we have to find out from this IP. So every IP will have net ID and host ID. Net ID is used to represent the network and the host ID with the computer number in that network. So for this, we have IP classes: class A, class B, class C, class D, and class E. There are totally 5 classes of IP. So let me take class A IP address. In class A, the network, sorry, in class A, let me write the valid range of these numbers are starting from 0 to 127 to 0 to 255, 0 to 255 to 0 to 255. This is my valid range in class A. Any number starting from 0 to between 0 to 127 is part of class A IP. So what is there in class A? What is the network and what is the host portion? How can I identify? So the first one is the network, next one is the host, host. So you can see the first octet is the network, the rest of all other octets are host. So the IP, I can use the IP, see, IP C1FA. If I am using IP 192 series, immediately every IP will have a mask. So this mask is used to identify the network portion and the host portion. So from class A IP, by default, we call it as subnet or network mask. Both are same. 255.0.0.0. Why? Because first octet is network. That's why it is filled. It is constant. Other octets are used to identify the computer numbers. Computers, and we can use as computer numbers. So that's why 0.0.0. This first octet is reserved. Other octets can be used for the computer. That's why the customized mask is 255.0.0.0. Sorry, the subnet mask. It is the subnet mask. The first number is reserved. Network. You can't change that number. If you change that number, it means your network is different. So just I can use some. Okay, let me show you. So here I logged in as administrator account. Go to my network places, right click properties, status, TCP IP properties. Here I'm using some IP 200.200.200. Suppose if I want to use class A, means 0 to 127. 10 is a part of class A. 10.25.24.1. So what is the subnet mask? By default it is taking 255.0.0.0. See, out of 120, let me take 126. 126 dot any number 255.255.0, not 0. 0 cannot be accepted. still I can see subnet mask as 1.255.0.0.0. So if I am taking 128.0.2.1.3, you can see 128 means out of class A. 127 is the class A, till class A. 128 is the class B. So you can see subnet mask has been changed because 128 onwards the network is class B. Let me use that system as an example. 0 to 127 number, anything, this is class A and your subnet mask will be 255.0.0.0. Am I right? Now, how many networks I have in the class A? Number of networks in class A. So 0 to 127, altogether 128 networks. Am I right? But out of 128 networks, 2 networks are reserved. 2 networks are reserved. Zero number starting IP cannot be started with 0 number. Means 0 number is reserved. IP cannot be started with 127 number because 127 is a loop back. Let me use. How can I use 0? 0.0. No, 0 is not a valid entry. Specify anything 1 to 223. Let me use 127. 127 also it is not used because 127 is reserved for loopback addresses. So what is loopback address? Loopback is for self-testing, TCP/IP testing. So out of 128, 2 networks are reserved. It means 0 network and 127 network. So altogether 126 valid networks exist in the class A. And number of computers in per network in class A. 255 computers. It goes to 1.62 crore computers. I guess it has to be calculated. Let me calculate. 255 into 255 into 255. 1.65. 1.6. This per network can accommodate these many number of computers in the class A. Like this, I have 128 networks. You can imagine how many networks I can connect in class A. So in class D, I just want to give 128 to 191 dot 0 to 255 dot 0 to 255 dot 0 to 255. This is my class B network. Subnet mask for class B IP addresses are 255.255.0.0 because net IDs concept comes with network host or first 2 octets are networks and remaining 2 octets are hosts. You can understand it. Total network 64 into 255. total computers per network, 255 into 255. So you can check total 255 into 255. It is only 65,000 per network. 1.6 crore computers to 65,000 per network. You can imagine. Class A network is a very big network, and Class B network is, it comes down to 1.6 crore computers to 65,000. But here, instead of 126 networks, I can accommodate 64 into 255 networks in the Class B. Class C, I have NetID, host ID. The number goes to 192 to 223. This is my Class C network. Subnet mask will be 255.255.255.0. So my IP, current IP, what is my current IP? 192 means it comes in the Class C network. 192 to 223. Any number from 192 to 223 is a Class C. So how many total networks in Class C? 32, 255, 255. This is my number of networks. You can see in the Class C. Total computers per network. You can tell me now. How many computers per network? 255 computers per network. Because class NetID, only one host ID remaining in the Class C. It means 192.168.0 is the different network. 192.168.1 is another network, because first three octets are NetIDs in the Class C. So I can use 1 to 223 numbers in the first octet to represent the IP addresses for computers. So Class D 224 to 239. First octet, remaining octets will remain same. It is called multicast IPs. Uses for video chat and conferencing from group IPs. We call it as group IPs. Class E. I'm sorry, this is 239. 242, 255. Reserve, and you cannot use this IP. Let me check. If I am using 224, 224 is not a valid entry because 223 is the last one. Why? Because 224 onwards multicast IPs. So this is how we use the IP addresses in the intranet. You are using Class A IP address or Class G or Class C. There is another concept called customized concept. In Class C, my capacity is 255 networks, 255 computers. So I want further to these 255 networks, 255 computers to be divided into smaller networks. Then subnetting will come into the picture. If you want to divide a big network into smaller networks, then you have to subnet. Even that is possible. And that is all the customization. But this is the standard as per the protocol, as per the rule. Okay, these are the IP addresses. How do you allow the IP addresses? There is a public standard rule. Any questions on these IP addresses? Did you understand? I do know. I guess you know already all the class A, class B, class C. Then I want to refresh. I guess. Reserve IPs 0.0.0.0 default 127.0.0.1. No network, no IP will start with 127. Loop back IP 255.255.255.255. Broadcast IP. Note, in every network, first IP called default IP and last IP is called broadcast IP. So how can I, for example, I just want to check what is the product here. Local. See, my network is 192.168.0.0. The first computer number is 0, default IP. 192.168.0.255. This is the last IP. Broadcast IP, where in this network, every network, the first IP is called the default IP and the last IP is called the broadcast IP. Unicasting, one-to-one communication. Multicasting, one-to-many communication. Broadcasting, one-to-all communication. Isn't it? Unicasting means point-to-point, source-to-destination communication. Multicasting is one person to group of persons. See, these three are the three are in the conference. So this conference will have a IP and it is called group IP. We call it as multicast IP. Broadcast IP means communicating to all the people in the network. Just like shouting in a room so that everybody in the room can hear my voice. It is broadcasting. Multicasting is a group of people, not all. Unicasting is only point to point. This is about the IP protocol. I guess you may have some questions. Okay? You have any questions? I just want to refresh everything because I don't want to, after starting our concepts and during installation we will be giving IP addresses. And I just want to refresh before I go for any further concepts. Let me save this. I guess you already have that some information about these concepts, but just I want to give an overview. This you cannot use this anywhere. It is reserved for some specific purpose. Apart from this, in each network, the first IP and last IP is also reserved. Default IP and broadcast IP. Other IPs in between, all other IPs can be used for computers. Yes, let me forward. Just go through these later on. IP and other, no, 1, 2, okay. I'll forward all these 3 files. 2, 3, 1, 2, 3. 3 documents. Can you accept these documents so that you can save? And just stop me if you have any questions. You can save all these 3 documents. I'll ask Elizabeth to join at least tomorrow so that we can start SAP basics and introduction sessions from tomorrow. See, most probably from next week I may change the timings. We'll start the session half an hour or an hour earlier. Okay? Let me check and with the existing batch. This week most probably my sessions will be completed for my previous batch. The next week, this Friday, I'll tell you. One more file has to, Bob, you also accept 2 more files. You can accept simultaneously. You can accept at a time. Instead of 1 by 1, you can accept at a time, all the 3. One. Okay, one more. You can see my desktop. One more is there. You want me to send it again? Yeah. Can you see it now? You can save it now. Three. Okay. So we'll start tomorrow. I mean, SAP introduction and SAP introduction concepts.
I'll take a look at the notes. If I have any questions on the IP,
Yeah, please.
bring it up tomorrow.
Okay. Okay. If I have any questions, even in subnetting and if you want subnetting concept, then I need to spend some time this weekend. I'll tell you this weekend. I see. If you need any other concepts, just like subnetting and other concepts, we can schedule the weekend other than SAP related. Okay.
Okay. Are they going to send a package that, you know what, I got to give you my email address because
Hey,
you get the,
STP link has been sent to Ravi, I guess. Ravi, did you receive the STP link?
Yes, and I downloaded all the stuff.
You can just forward to the same link to Bob.
Bob, what's your email address?
it's RW underscore Hudson, HUDSON
Okay.
at yahoo.com.
Okay, I'll see you tomorrow at the same time. Okay. Yep. Bye.